You should have your guided notes. Here we go. All right, so here's our path of least resistance. Yes, Pat. We'll talk about that later in the week. All right, not trying to put you off. I just want to make sure we get as much done as we can with the law of cosines. So, quick refresher. If it's a 90, has a 90-degree angle, right triangle, we can use SOHCAHTOA Pythagorean theorem. But if it's not, we have to use the law of sines. If it's, do you remember? ASA? AAS, and thank you for saying the bad word backwards. SSA. Okay? Not straight out saying that. You know what I'm saying. So those are our three law of sines. Now, if it's not law of sines, it needs to be the law of cosines. So this is our path. We ask ourselves, well, what if it's not SSA or AAS or ASA? All right. We have what's called the law of cosines. Now, before you start writing this down, just pause for 1 second. Do you notice how these are all three the same, just with different letters swapped out? Before you write this down, because I think it's going to help you to reinforce it when you write it down if you know what to look for. What do you notice? Do you see how if A is here, little a is that side? If little a is here, big A, angle A is over there. And how would I solve for side A? I'm one step away. I would have to do what to both sides? To solve for A. It's A squared over here right now. Square root both sides. So guess what? If you're looking up here and you're like, oh, I need to solve for side A, this is the one you want. Angle A goes over here. But what if you're trying to solve for side B? Wouldn't you use the second formula? And angle B goes over here. And what if you're trying to solve for side C? Angle C goes over here. Okay? And we'll notice a couple other patterns here in just a second.
Why doesn't the law of sines always work?
Why doesn't it?
Yeah.
Because it's the sine of angle A over side A equals sine of angle B over side B. So how many angles are involved in the formula? How many angles do you see in the law of sines? 2. How many sides? 2. How many unknowns can you have in that formula? 1. So you either need to know 2 angles and a side or 2 sides and an angle. Make sense?
Yeah.
But what if you don't know any of the angles? Well, that law of sines is not going to work.
Yeah.
That's kind of why. As you're writing these down, if you see the pattern, it's going to be really easy to memorize. Anybody have a couple observations? And I'm not saying it's obvious, but now that you've read it, are there a couple observations, ways we can memorize this pretty easily? None? Kind of looks like the Pythagorean theorem, right? And then if I have whatever little letter I have over here, the matching letter has to go right here. So this letter and this letter gets repeated here and here. Again, I'm not saying it's easy to memorize. I'm just saying here's some observations to just notice as you go through. And if you write it out a couple times, you'll have it memorized. Okay. Now, the letters will change as the letters in the problem changes. So we'll adapt it to whatever triangle we're working with. When do we need it? Well, when you have SAS or SSS. You're going to use the law of cosines if you have SAS or SSS. Just like Tally asked about using the law of sines, and and I told her you either need to know two angles and a side or two sides and an angle because of how many unknowns there were. How many unknowns are in the law of cosines? That's not a very good way to ask it. Not how many unknowns. How many variables are used in the law of cosines? Someone said it. All three what are used? All three sides are used and an angle. So 4 pieces, right? 4 pieces. Do we need more time or are we good? All right. Solve the right triangle. So first thing you should notice, now this wasn't even an option before because it was only going to be the law of sines for us, right? But the first thing you should do, because these are all going to get mixed together here in a little bit, in a day or two. The first thing you should look at is, do I have ASA, AAS, SSA, SAS, or SSS? Okay? And as you look at this triangle, remember, just because it has 2 sides and an angle doesn't force it to be SSA or SAS. It depends on where the angle is, right? And you see how this angle is where the 2 known sides come together. So this is SAS. This is SAS. That tells us to use the law of cosines. Abbreviation, law of cosines. Just a nice reminder for yourself to use the law of cosines. Well, I have z, little z, equals 35. I have side x is 30, and I have the measure of angle y is 110. Which piece am I going to use first? Which side or angle do I want to find first? Any idea? I know you haven't done this before, but just knowing that there's 3 sides and an angle used in the law of cosines. What am I going to try to find? Little y. Do you agree? Why? Because I have angle y. Makes sense that I would want to write little y. So it could have been x squared equals. It could have been y squared equals. It could have been z squared equals. We have the flexibility to write the formula 3 different ways. We're going to write it with the y squared equals first because we want to find little y because we have the cosine of angle y way over here. We already know the cosine of angle y. I'm going to write it out generically just to help you memorize the formula. Okay, we're going to write it out with all the letters and then we'll plug the numbers in. Well, if my letters are x, y, and z, and I have y squared here, isn't it x squared plus z squared minus 2 times x times z? Remember, those letters get repeated right after you write them squared. They get repeated with multiplication. -2 times those 2 numbers times the cosine of the angle that matches the side. Everybody with me so far? So y squared goes first. Y is our unknown. Equals 30 squared plus 35 squared minus 2 times 30 times 35 times the cosine of 110 degrees. Do not round your answer until the very end. I can see you guys are anxiously typing things in. Here we go. 30 squared. We're gonna type this in all at once. Plus 35 squared minus, not negative, minus 2 times 30 times 35 times the cosine of 110 degrees equals. And what do we have to do with that number? Square root it. So 2843.24. I'm going to write this out just now. I'm telling you not to round. The only reason I'm writing this out myself is to point out something. So this is not something you're actually going to write down. 2843.24. Square root both sides. So I'm going to square root the answer. I have not rounded yet. I get 53.32. 53.32. Is that a reasonable answer for this triangle? Yeah, I mean, that's going to be the longest side, isn't it? Okay, don't call it the hypotenuse. This is not a right triangle, but it's going to be the longest side. Pretty easy, right? Type it in the formula. Square root both sides. Don't forget to square root both sides. Right? But we're asked to solve the triangle. So we had to find little y, and then we're going to have to find the measure of angle x and the measure of angle z. Any ideas? We could use the law of sines now, can't we? All right. So we'll do the law of sines, and let's say we want to find z first. We'll do the measure of angle z. Nope. Sorry. Sine of angle z over 35 equals the sine of 110 over 53.32. Now, we've done enough law of sines. I'm going to go ahead and just skip a few steps and solve this in the calculator. So on the quiz, you should be asking yourself, what should I write down? What should I show? If you guys show this setup in here in green, and you show this setup in blue, right here, with the numbers, I understand from there it's calculator work. Okay, it's okay if you go to the calculator from there, but I need to see the setup. Does everybody understand that? Show me the setup, and then you can type stuff in. So here I'm multiplying 35 times the sine of 110. 35 times the sine of 110. Close the parentheses. If you're getting mistakes, it's because you're not closing that parenthesis. All right? Divided by 35 times the sine of 110, divided by 53.32. And if you ask me this question on the quiz, I'll say I can't help you. All right. If you put 0.617, what did you forget to do? Sine inverse, right? Because that's the sine of z equals. To find z, I need to take the sine inverse of that answer. Sine inverse of the answer, and I'm getting 38.08 degrees. So z is 38.08 degrees. Y was 53.32. And if you're feeling lucky, risky, whatever you want to call it, you're going to add up those two angles and subtract from 180 to get the third angle, right? Could you use the law of sines again to find the other angle, angle x?
Yeah.
You could. Some of you will. That just confirms that your other answer is correct. All right? It's kind of a safe way to do it. Help me out. What do we get here? 148. So 180 minus 148. What'd you get? Like 31 point something? 31.92 degrees. We just solved the triangle. We started using the law of cosines. Every single time, here's a helpful hint. Every single time, if you start using the law of cosines, then from there on out, you're going to use the law of sines after that. Try to finish it off. What if you have to solve a triangle and you start off by using the law of sines? you keep using the law of sines. All right? Let's do another one. Now, I know some of you like to work ahead. All right? Like to try these on your own. Here's a word of warning for you. If you're given, let's back up. What's this triangle? What type of triangle is this? SSS. Very good. SSS. So we're going to use the law of cosines. Here's my helpful hint to you. If it's SSS, find the largest angle first. Find the largest angle first. Here's what you're going to avoid if you find the largest angle first. Okay? You're going to avoid that ambiguous case of the law of sines last week. Do you remember what that was? That one triangle that the side could have been here or it could have swung over here. And that angle could have been acute or obtuse because we didn't know anything about it. We didn't know where it was going to swing and hit. So it wasn't quite clear to us which angle to pick. It could have been both. It could have had two triangles. Okay? So here's what I'm trying to say. What if you found this angle first? T? Do you agree you're going to find the angle using the law of cosines? And then if you go to do the law of sines after that, you may have an ambiguous case. But, let me back up. I'm talking a lot. I want you guys to tell me this. For the law of sines, what was the relationship between the one angle we found and the other angle we found? It could have been both. What were they compared to each other? They were supplementary. Very good. Right? So it could have been the acute angle or obtuse angle. I have good news. There is no ambiguous case in the law of cosines. So if you find the biggest angle first, then when you go to do a law of sines, there's no other obtuse option. You've already found the obtuse angle. It's only acute from there. Does that make sense? Let's say it again. If you use the law of cosines to find the biggest angle first, which angle is the biggest angle? S. There's no ambiguous case. You found the biggest angle. If it's an obtuse triangle, you found that obtuse angle. It can't pop up in the law of sines then. All right? So find the biggest angle first. Well, if that's our rule, then what letter goes over here all by itself squared? If we're finding angle S, what goes over here? Yeah, let's write it out with the letters first. So little s, good, equals little r squared, oh, not this again, plus little t squared minus 2 times r times t times the cosine of angle S. I highly encourage you for this homework to just write out the formula generically with letters every time. Okay? You're going to have it memorized by the end of the homework. All right. So it's filled in. 13 squared equals 11 squared plus 7 squared minus 2 times 11 times 7 times the cosine of angle S. Everybody understand how we got that? Now, if you are working ahead, I want to strongly encourage you to pause for a second. Okay? This is the hardest thing we're doing today, right here. Solving for an angle. Do you guys see how we're going to solve for angle S? What are our order of operations going to be to solve for S?
Combine.
Like, do you agree these need moved over? Okay, I better talk about something real quick. You guys look really confused. If I say solve for x, go for it. We'll start off with a simple problem. Go ahead and solve for x. What'd you get? Go for it. Anybody brave enough to tell me their answer? Huh?
1 1/3.
1 1/3? 4/3? Yeah, look. Don't you subtract the 2? Subtract the 7? And then divide by -3. Agree? Now, I'm leaving those uncombined for a reason. You'll see why in a second. Tell me.
Could you also subtract or add the 3 over and then subtract the 5? And it'd always be the same answer?
Add the 3x over?
Yeah, add the 3x over.
And then subtract the 5.
Yeah.
In this case, yes.
Would it work always?
Yeah, in that case. Now, we have something more complicated. I just want to make sure you guys are okay with the order of operations. Do you understand what I did?
Yes.
Okay. So, the reason I'm showing you this is because what we're about to do is going to go in the calculator all together, and this is kind of risky, but it's worked well. Do you agree? S is the variable. The cosine of S is an operation. Cosine of S. That's together. Times 7 times 11 times -2. Isn't this all one chunk with multiplication? So if I want to move these over to get cosine of S by itself, I have to subtract. So I have 13 squared minus 11 squared minus 7 squared equals -2 times 11 times 7 times the cosine of angle S. How do I get rid of the -2 times 11 times 7? I know I can combine them, but they're going to be huge numbers sometimes. But how do I move it to the other side in general? Thank you. I don't add, correct? I divide. I know we laugh, but like it happens more than you think. So I'm dividing both sides by -2 times 11 times 7. -2 times 11 times 7. So the cosine of S is 13 squared minus 11 squared minus 7 squared all over -2 times 11 times 7. I'm going to show you how to do this, and I'll show you why we're doing it this way and what we're avoiding, okay? Just hang with me. So in our calculator, we're going to use parentheses. We're going to do 13 squared minus 11 squared minus 7 squared divided by parentheses. Please use parentheses. -2 times 11 times 7. Is everybody getting that number? Bottom right next to the equals.
Yeah.
Everybody see the negative button? Bottom row, second from the right. Is everybody getting this number?
Yeah.
But that's not angle S, that's the cosine of S. So how do we uncover the angle?
Inverse.
Cosine inverse of that answer, I'm getting 89.63 degrees. 89.63. .63 degrees. You what? What's wrong?
I can't write smaller.
Is everybody? Does this make sense? How I solved for the cosine of S? Okay, now let me explain why. I'm going to give you some options. Okay, I'm going to explain why I did it that way, and why or what students will do sometimes incorrectly. Because I don't really care which way you do it. I just want to warn you of some things I see, and this is why I'm teaching it this way. All right. What if you're like, well, I just rather work with the numbers themselves. It's kind of confusing what you did. Well, this would be 169. 11 squared plus 7 squared is 170. negative 2 times 11 times 7 is that. So many times I have students subtract the 170 and the 154, okay, just because they're there. All right. That's fine if you want to do it that way. Couple things. These numbers are pretty small. Sometimes the sides would be like 40, 50, 60. These numbers, when you square them and add them together, are going to get huge. All right. And why did I explain it the way I did? Well, look at the pattern of the law of cosines. If you're solving for this angle over here, aren't you going to subtract this number and divide by this number every single time? I mean, it's the law of cosines. It's the formula. Every single time, you're going to take this number, subtract this number, and divide by those three. Every time. So you might as well let your calculator do it for you. Does that make sense? I mean, it's fine with me if you choose to do it that way or the other way. I don't care. I'm just saying from my experience, if it's that way every time and you don't want to work with those huge numbers, you can subtract, divide. So what are your steps for law of cosine? Solve for the angle, subtract, divide, and then cosine inverse to uncover the angle. Subtract, divide, and then cosine inverse. We're going to skip a problem because I want you guys to try one of those that we just did. Okay? So this is SSS. What angle do we find first if you're given SSS?
The big angle.
The biggest, which is which angle in this problem?
L.
L. Tally.
For the last question, do you just repeat the same process?
Oh, I'm sorry. I didn't solve the rest of the triangle. I forgot to solve the rest of the triangle. How would we do it from there?
Like, would you repeat the same operation?
One side.
So now that we have S, we can use the law of sines. So if we want to find R, if you're good with the law of sines from here on out, you guys agree we can use the law of sines from here on out? Okay. If you want to move on to that next problem, I'm fine with that. If you want to see finishing off this problem, I would do the sine of 89.63 over 13. And then pick an angle tally, R or T, I don't care. R. So equals the sine of R over what? 11. And then you just cross multiply and then sine inverse.
Thank you.
Yep. Just get 112.41.
Yes.
Awesome. Just so I'll do the same thing you guys are doing. How many of you are trying to type it in all at once with the shortcut? How many of you are solving each part and then typing it in separately?
Oh, yeah. Oh, that's actually surprising.
Check your angles. You got them all done? It's easy to like once you switch between law of cosines, law of sines, it's easy to accidentally type in like second sine or second cosine when you're doing the other one. Like it's easy to do that. So just double check your work. And if you're getting an error, really double check, because it's most of the times if you get like a domain error, it's because you're using the wrong inverse, like maybe sine inverse when it should have been cosine, vice versa.
Is it that you can't put, like, I noticed this with the homework because I kept getting stuff wrong. Is it that you can't put a whole number in a sine or cosine inverse?
Yeah.
Okay.
Yeah. And remember when I showed you the graph of sine?
Yeah.
How it stayed
Oh,
between
yeah.
-1 and 1.
Yeah.
If you put anything above or below that, it's not going to give you an answer.
Yeah, I just kept getting stuff like that.
How do we feel about the SSS situation? SSS is the most difficult it's going to be.
Okay.
Okay. Why? Well, if it's SSS, you have to find the angle. And if you have to find the angle, you have to do subtract, divide, and then cosine inverse. If it's not SSS, quick refresher. We'll do one more of these. We're going back to this one. What side do you find first?
The 99C.
The one across from 99, which is called C. Why do we find that one first?
Because you have the angle.
Yeah, because we have the angle. So the C goes here, C squared equals A squared plus B squared minus 2AB cosine of C. And remember, this one, you don't need a cosine inverse. We don't need a cosine inverse, right? Because we're trying to find the side. So we're doing side C. We have 12 squared. We have 15 squared times 2 times 12 times 15 times the cosine of 99. Everything on the right side of this equation is a number. The only thing I have to do is square root to get my answer. So I'm going to type all that in. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 99. Don't forget to square root answer. I get 20.62. C is 20.62. It's got to be the longest side, right? I mean, 99's got to be the biggest angle. And then from there, I've got my angle inside pair. I can use the law of sines to finish it off. Anybody completely confused?
No.
It's about as tough as it gets. When do we use law of cosines? When we get SSS, SAS. Okay. SSS, SAS. Yes.
How many homework problems do we have?
Yeah.
This is like 3 hours long.
Have you looked at them yet?
I'm still trying to say it.
I've got all the concept programs done, all of them. Like
I know,
7,
6, 11.
4. It was like 11 problems.
I'm gonna cut. Yeah, I'm actually gonna cut out a few.
We're not adding a couple.
All right. 31, 33, 35. You're gonna have to make the decision between law of sines, law of cosines. And my hint for 31, 33, 35. No, not a hint. My requirement. It just lists the information about the triangle. It doesn't actually draw the triangle out. So draw the triangles. There's only 3 of those. There's only 3. Draw the triangles first. Label the triangles.